This is for geometry 3.4.4, which is all about a 30, 60, 90 triangle. Okay, so just before we get started with the questions, a 30, 60, 90 triangle I have shown you right here at the top. And basically you have your angles are 30 degrees, 60 degrees, and 90 degrees, which is that little box in the corner. That's why we call it a 30, 60, 90 triangle. And then it is a special right triangle because those specific angles create a special ratio of sides. So what we know is, So what we know is that this, the side beside the 60-degree angle, we're going to call that the short side. So the short side, or the short leg, let's say that, the short leg, which is beside the 60-degree angle, is x. So it could be 1, it could be 2, it could be 17.3, whatever it is, we call that leg x, okay? And then the longer leg, so the other, not the hypotenuse, but the other leg, which would be, I'm going to go ahead and highlight this a little bit. So this other leg right here is x radical 3 is how we would read that. Now, what that means is that whatever the short leg is, we multiply it by the square root of 3 or radical 3, and we get the longer leg. So that would be the leg of the triangle beside the 30-degree angle. So in between 30 degrees and 90 degrees. And then the hypotenuse, which is our special side, that's always going to be the longest side of our triangle. So the hypotenuse, I'll highlight this in green, is 2 times the shorter side. So it's whatever the shorter side is, which we called it x, times 2, okay? So if you have this one, if you have the short side of the triangle beside the 60-degree angle, if you have that, you would multiply it by the square root of 3 to get the longer leg, and you would multiply it by 2 to get the hypotenuse, okay? Those are kind of like our shortcuts. So some of these you'll see we have that, some of them we don't. Okay, so let's go to the first question. It says, which of the following could be the ratio between the lengths of two legs? So the lengths of the two legs of a 30, 60, 90. So instead of like going back up to the top, I want to draw this again. I think the more that you see it, the easier it will be to remember it. So here's a 30, here's a 60, and we have our 90 at the bottom. And then I remember x is the side beside 60 degrees. X radical 3 is the side beside 30 degrees, and then the hypotenuse is 2x, okay? I believe in Apex they use S. I like to use X just because I think my S's look like 5 sometimes, so just to kind of cut out any confusion. Okay, it's asking you for the ratio between the lengths of the two legs. That would be this leg and this leg. So to write it as a ratio, we write X, the first leg, and then a little semicolon, or a colon actually, and then the other leg, x radical 3, okay? Now, I'm going to simplify this. Let's say, for argument's sake, let's say x is equal to 1. So 1 to 1 radical 3, or that's just really 1 to radical 3. That would be the simplest form of the ratio between the two legs. So if you look at your options, 1 to the square root of 3, so we're just saying, okay, pretend that this side right here is actually 1 instead of it being x. Then that's where this option comes from, okay? Now, all of the other options, there's A through F. So A, B, D, E, and F, all of those options, we have to kind of figure out if they would reduce to be the same thing as this ratio. So what I would like to do, we know that a ratio means that you divide the two numbers. So I actually want to do 1 divided by the square root of 3 and see what that equals. And I just think this is the easiest way, instead of trying to like simplify radicals and that stuff, this is the easiest way to figure out which of those ratios, like A through F, which ones are actually equal to 1 radical 3, okay? So when I do that, if I do 1 divided by the square root of 3, I get 0.577. So what we want to do, 1 divided by the square root of 3 is 0.577. We want to see, okay, is this equal to 0.577 if I divide those two? So there's a couple I can eliminate automatically. So this first one, A, radical 2 to radical 2, since those are the same, if I were to do the square root of 2 divided by the square root of 2, I know that would just be 1. Any number divided by itself is 1. So I just eliminate that option immediately. And then I also see this one, D, square root of 3 and square root of 3, I can eliminate that. They have to be different, okay? So now for B, I want to kind of test, and I'm just going to do this in my calculator. I want to test, is the square root of 3 divided by 3 the same thing as this? Or when I divide it, do I get the same thing as that decimal? Okay, so if you do the square root of 3 divided by 3, you do get 0.577. That means that those two lengths could be the sides of the triangles as well, or the legs of the triangle, okay? Then I want to check for E right here, square root of 2 divided by square root of 3. Now, I know in my head that that's not right because here I had the square root of 3 on the bottom, square root of 3 on the bottom, so these aren't the same, then it can't be equal. But basically, if you just want to test it, again, this is kind of the easiest, I think the easiest way to solve this problem. You get, when you divide that, 0.816, which is no good. Okay, so I'm going to cross that off. And then last one, 1 divided by square root of 2. Again, I know that's not right because this top is 1, this top is 1. That means the bottom should be the same. They're not. So if I do 1 divided by square root of 2, in my calculator I get 0.707. And so that one doesn't work. And then you're left with B and C. Those are the two possible side lengths. Okay? All right, question 4. What is the length of the altitude of the equilateral triangle shown below? Okay, so what I would like you to do, I'm actually going to delete part of this. Let's just, for argument's sake, let's just scratch this off. I want you to look at just like half of the triangle. So we can see now we have a 30, 60, 90. This top angle is 30, this is 60, this is 90. We have this is 3 square root of 3. We don't know this leg, that's what we're trying to find, and the hypotenuse is 6 square root of 3, okay? What is the length of the altitude of the equilateral triangle? So we're looking for this right here. Okay, so what I would do is I would say I know that this side beside 60 is x, this side is x radical 3, and this side is 2x. So since I have this side that's x, I'm going to go ahead and say x is equal to 3 square root of 3. Okay, and then all I really have to do, I'm going to plug that in here in order to find A. So we know A, that altitude that we're looking for, is equal to x times the square root of 3. And we just found right here, x is 3 square root of 3. So I'm going to plug that whole number in right there for x. So we're going to say, if I plug that in, 3 square root of 3, and then we have to multiply it by this square root of 3. So we have times the square root of 3 again, okay? So 3 square root of 3 square root of 3, basically. Now, if you multiply, this might be new to you, but if you multiply a radical times itself or a square root times itself, you just get the number inside. So it's like 3 times square root of 3, and square root of 3 is the square root of 9, which is 3. Okay, so 3 times 3, and that's just 9. And so that's how we get that answer. All right, next one is very similar, and we're going to do the same thing. I'm going to scratch this off. We're not going to like redraw the whole triangle this time, but I am going to say, remember the side beside the 60-degree angle is x. This is x square root of 3, and this is 2x. Okay, so this time we have x is equal to 4. So x is equal to 4. And then to find A, this length right here, I know A is equal to x radical 3, or x square root of 3. So all I have to do is take that 4 and plug it in for x. So we have 4 times the square root of 3. Now that doesn't really simplify. There's nothing to cancel out with a radical, so that's actually your answer, and you'll find it right there. All right, question 6. Which of the following are true statements about a 30, 60, 90 triangle? And we're just going to go through all of them and kind of eliminate. So before we do that, let's draw our 30, 60 triangle again. 30, 60, 90. So 30, 60, and then I know this side is x, this one is x radical 3, and this one is 2x. Okay, so A, the hypotenuse is the square root of 3 times as long as the longer leg. Okay, so the longer leg is x radical 3, and it's saying if we do that, x radical 3 times the square root of 3, we should get 2x. That doesn't work. That would actually give you 3x. So this one is not correct, okay? And I'm going to just kind of erase as we go. All right, the next one, whoops. So this one was no good. The next one, the hypotenuse is square root of 3 times as long as the shorter leg. So again, the hypotenuse is square root of 3 times as long as the shorter leg. Here's the shorter leg. In order to get the hypotenuse, we would just multiply by 2. So again, that one's not correct, okay? So let's erase that. Next one, the hypotenuse is twice as long as the longer leg. So that means we start with the longer leg. If we multiply by 2, we should get 2x. So x radical 3. If we multiply by 2, that doesn't give us 2x. It gives us 2x radical 3, or 2 radical 3x, technically. So nope, that one's not good either. Okay, let's erase this. The next one, the hypotenuse is twice as long as the shorter leg. So here's the shorter leg. If I multiply by 2, do I get the hypotenuse? Yes, finally that one does work, okay? So the hypotenuse is twice as long as the shorter leg. The next one, the longer leg is radical 3 times as long as the shorter leg. So start with the shorter leg, multiply by radical 3, we get x radical 3. Yeah, that would be right. So again, start with the shorter leg, multiply by the square root of 3, and we get x square root of 3. That does check out. It's kind of, the way that it's worded is kind of strange to actually kind of show your work. And then the last one, the longer leg is twice as long as the shorter leg. No. So the longer leg we just said is square root of 3 times as long as the shorter leg. So these are kind of the same thing, but only one of them can be true. So no, that's not correct. The hypotenuse is twice as long as the shorter leg. Okay? So those are just about the ratios. Number 7, which of the following could be the ratio of the length of the longer leg of a 30, 60, 90 triangle to the length of its hypotenuse? Okay, so again, we're going to draw this one more time, at least one more time. So you've got 90, 30, 60, and then we know this is x square root of 3, and 2x. This time it says the longer leg, which would be this one, x radical 3, to the length of its hypotenuse, 2x. So x radical 3 to 2x. And then what we're going to do again is simplify this. So let's say, just for argument's sake, let's say we plug in 1. So 1 radical 3, and then 2 times 1. That would simplify to the square root of 3, and then 2. So radical 3 to 2 is the simplest form of the ratio. Okay, so this is kind of like what we did at the beginning. So if you find that one, that's definitely an answer. Radical 3 to 2, there's that one. And then remember on that first question, we said, okay, now let's actually divide those and see what our decimal is. So if we do the square root of 3 divided by 2, square root of 3 divided by 2, we get 0.866. So the square root of 3 over 2 is 0.866. What we want to do is now check, are any of these other ratios equal to 0.866? And I'm just going to do it in my calculator this time, okay? All right, so the first one, if I do 3 divided by 2 radical 3. So I'm just checking this right here, that ratio, to see if it gives me the same decimal. 3 divided by 2 radical 3. I do get 0.866. Okay, so that one is good. 1 divided by the square root of 2. 1 divided by the square root of 2. I get 0.707. That does not work. Next one, 2 divided by 3 square root of 3. Nope, I get 1.154. That doesn't work. Next one is square root of 2 divided by square root of 3. Square root of 2 divided by square root of 3. 0.816. That's close, but not the same. And then the last one, 2 divided by 2 square root of 2. 1.414. So there's only 2 A and C that work, okay? All right, number 8. A certain triangle has 30-degree angle and a 60-degree angle, which must be a true statement about the triangle. So we know, first of all, we know that this is a 30, 60, 90 because if one angle is 30 and one angle is 60, and there's 180 total degrees in my triangle, all that's left in this other unknown angle is 90 degrees, okay? So 30, 60, 90. Then again, we have our ratios we've been talking about. So x square root of 3, and 2x. Okay, so it's kind of like the, I think question 6 that we did. Yeah. The longest side is twice as long as the shortest side. That's true. Here's my shortest side. Here's my longest side. That is twice as long. Let's just eliminate the other one. So the second longest side, that's right here, is twice as long as the shortest side. Nope, because they're not equal. The hypotenuse and the other leg are not equal. Two sides of the triangle have the same length. No, we know that's not true, because we know that because my angles are 30, 60, and 90 degrees. So since my angles, like if two sides are the same, two angles have to be the same. So since my angles are all different, my sides have to all be different. And then the longest side is square root of 3 times as long as the shortest side. Now, if that said the longest leg instead of side, that would be true, but it doesn't say the longest leg, it says the longest side. The hypotenuse is always the longest side, so no, that's not true, okay? So it has to be A. All right, question 9. Which set of values could be the lengths of a 30, 60, 90 triangle? So what we've been talking about is this ratio of sides. We have x is the shortest side, x square root of 3 is the longest side, and then 2x, or sorry, is the longest leg, and then 2x is the hypotenuse, which is the longest side. So this is the shortest to the longest. So this is the shortest side, this is the middle side, this is the longest side, okay? Okay, so we basically just have to find where we would plug in numbers, and like, so all of them, you can see the shortest side on all of these is 5. So if the shortest side is 5, I know I would multiply by 2 to get the longest side. So 2 times 5 is 10. So it has to start with 5 and end with 10. That automatically means this one is not right and this one is not right. And then the middle side would just be, we would just plug in 5 right here for x. So it would be 5 times the square root of 3. So it's this one right here. All right, last one. In a 30, 60, 90 triangle, below side S has a length of blank and the hypotenuse has a length of blank. Okay, so I'm going to fill in my x's here. So I know the side beside 60 degrees is x. The side beside 30 degrees is x radical 3. The hypotenuse is 2x, okay? And then we know the length of this one. So I'm going to say x equals 1. So since x is equal to 1, I'm going to plug that 1 in right here for x. So s would be equal to 1 square root of 3, or just square root of 3. I'm also going to plug it in right here for x. So h is 2 times 1, or just 2. So square root of 3 and 2. Those are our final answers. So square root of 3 and 2, that would be C.